this is Dr. Brown. I'm going to be going over the part 1 of the 1540 Calculus 1 Final Extra Study Guide. At some points I'll be pausing the video and asking you to try to work a particular problem. One of the things we need to be able to do is to use the product rule to calculate a derivative of a function where the function is a function of x times g of x. And as you know, the product rule says you take the first times the derivative of the second plus the second times the derivative of the first. So let's look at the first one here. To calculate dz dx, we see that the first, it would be called 8x squared, and the second would be e to the x. So looking at this, we would take the first, which is 8x squared, times the derivative of the second, which in this case is just e to the x, plus the second, which is e to the x, times the derivative of the first, which is 16x. And we can rewrite this sometimes as 16x e to the x plus 8x squared times e to the x. So that is the first problem. I'd like for you to now pause the video and try to work this second problem, and then I'll work it for you too. Looking at the video, looking at this particular problem, we have the first and then the second. And you can see we probably want to prepare the second one for taking its derivative by writing it as 5x squared minus 5x to the 1/2 power. And its derivative would be 10x minus 5/2 x to the minus 1/2, which as you can see would be 10x minus 5 over 2 square roots of x. So now we've got all the ingredients to take the derivative of the product, and so f prime of x is equal to the first, which is 2x to the 5th minus 2x cubed minus 6 times the derivative of the second, which we calculate over here, which is 10x minus 5 over 2 square roots of x, plus the second, which is 5x squared minus 5 square roots of x, times the derivative of the first, which is simply 10x to the 4th minus 6x squared. And that is this answer. Now another problem that we have to do is to use a quotient rule. And as you know, if you have a quotient f of x over g of x, then the first derivative is equal to the first, or the bottom, times the derivative of the top, minus the top times the derivative of the bottom divided by the bottom, or the denominator, squared. So let's do this particular problem. Following the quotient rule, we have the derivative is equal to the bottom, which is x cubed minus 9x squared, times the derivative of the top, which is 10x plus 1, minus the top and put it into parentheses, times the derivative of the bottom, which is 3x squared minus 18x. Divided by the denominator or bottom squared, which is x cubed minus 9x squared, quantity squared. Now, simplifying this, we would get, multiplying these two polynomials together, we would get x cubed times 10x, which is 10x to the fourth, x cubed times 1 is x cubed, minus 9x squared times 10x is minus 90x cubed, and then the last is minus 9x squared. And then we have the second product here. And remember, we have a negative here. And so we've got to take care of 5x squared times a minus times 3x squared. And that's going to give us minus 15x to the fourth. Then the 5x squared times the minus 18x with a minus in front of it is going to give us plus 90x cubed. Then we have the negative times the x times 3x squared is going to give us minus 3x cubed. Then we have the minus times the x times minus 18x gives us plus 18x squared. Now we've got to deal with the minus times a minus 1 times 3x squared is going to give us plus 3x squared. And then the plus 1 times the minus 18x gives us minus 18x. And this is all going to be over x cubed minus 9x squared. Now, simplifying all of this, we have 10x to the fourth minus 15x to the fourth. So we have minus 5x to the fourth. And then as far as x cubed is concerned, we have minus 90x cubed plus 90x cubed cancel. Then we have a plus x cubed and a minus 3x cubed, which gives us minus 2x cubed. And then we have, for the square terms, minus 9x squared. Minus 9x squared plus 18x squared plus 3x squared gives us 12x squared. And finally, the x terms are only minus 18x. And so that is the answer, all divided by x cubed minus 9x squared, quantity squared. It just takes a lot of multiplying and simplification. to get this answer. Now I want you to take a look at this problem and try to do this using the quotient rule. I'm going to pause, or you can pause the video and see if you can do it by yourself. Now, working this problem, we get the denominator, which is x squared minus 2x plus 2 times the derivative of the top, which is going to be 2x plus 2, minus the top, which is x squared plus 2x minus 2 times the derivative of the bottom, which is 2x minus 2, all divided by the denominator squared, which is x squared minus 2x plus 2 quantity squared. And now we need to multiply these terms out, take care of the x squared first, and we get x squared times 2x is 2x cubed. X squared times 2 is 2x squared. Taking care of the minus 2x times the 2x, we get minus 4x squared. And minus 2x times the 2 gives us minus 4x. And now we'll take care of the 2. 2 times the 2x gives us plus 4x, and then the 2 times the 2 gives us 4. And now taking care of this last part, we get minus x squared times 2x is minus 2x cubed, minus x squared times minus 2 is plus 2x squared. And now the minus times the 2x times the 2x gives us minus 4x squared. And the minus 2x times the minus 2 gives us plus 4x. And then finally, taking care of the last minus 2, we get a minus times a minus 2 times 2x is plus 4x. And then finally, minus times a minus 2, which is a plus 2 times a minus 2 is a minus 4. So you have to be real careful with your signs there. And then you get x squared minus 2x plus 2 quantity squared. And now we simplify this. And notice that we have 2x cubed minus 2x cubed cancel out. And 2x squared minus 4x squared is minus 2x squared. Plus 2x squared is 0. And then the minus 4x squared gives us all our x squared. So we have a total of minus 4x squared. Taking care of the x terms, we get 4x minus 4x is 0. Plus 4x plus another 4x is plus 8x. And you can see the constant terms are plus 4 minus 4. They cancel out. And so we get a much simplified expression, x squared minus 2x plus 2 squared in the denominator divided in to minus 4x squared plus 8x. And I'm sure you've heard us talk about remembering the chain rule. If you have y equal a function of u, which we have sometimes called the blob, and u is itself a function of x like g of x, then you first of all take the derivative of y with respect to u, and then multiply times du dx. So looking at this first problem, you can see that the u, or the blob, is going to be 5x fourth plus 4x plus 4x squared. So we're going to have to first of all take 8/5 times the blob, or u, 5x fourth plus 4x plus 4 over x squared to the 3/5 power. But we have to multiply it times the derivative of the blob. Now, to do that, I would write the blob, or u, as 5x to the fourth plus 4x plus 4x to the minus 2. And so the derivative of this would be 20x cubed plus 4 minus 8x to the minus 3, which, writing that here and rewriting the minus x to the minus 3 as minus 8 over x cubed, we get this answer. So there is the derivative using the chain rule. Now, you can pause the video now and see if you can write down the derivative of this function using the chain rule. The derivative, of course, is going to be 308 times u, which is 2x to the fifth minus 4x to the fourth plus 3 to the 307th power, times the derivative of the u, sometimes called the blob, which is 10x to the fourth minus 16x cubed. And those are two examples using the chain rule. We also know that you have to figure out how to calculate integrals using the substitution rule. You can also see a video on the website strictly on substitution. Notice that for this particular problem, the whole idea is to find a part of the function whose derivative is just sitting there in the integral. So in this particular case, you would pick u equal 1 plus x to the fourth and write that du dx equal 4x cubed. So du is equal to 4x cubed dx. So as you can see, 4x cubed dx can be replaced by du, and the 1 plus x to the fourth is u, so the integral becomes du over u to the fourth. We have to replace the upper and lower limits of x by upper and lower limits of u using the substitution. So we would plug in for the upper limit x equal 1 and get the upper u is equal to 2, and then plug in x equals 0 and get the upper, or the lower u is equal to 1. So we have an integral from 0 to 1 of 1 over u to the fourth du, which we can rewrite, this is integral from 1 to 2, 1 to 2, u to the minus 4 du is equal to u to the minus 3 over minus 3 between 1 and 2 is equal to minus 1 over 3 u to the third power between 1 and 2. And so we get, plugging in 2, minus 1 over 3 times 8 minus, plugging into 1, minus 1/3. So we get minus 1 over 24 plus 1/3 equal minus 1 over 24 plus 8 over 24 equal 7 over 24. So the answer is 7/24. Now, pause the video and look and see if you can work this second problem. This particular problem, we want to let u equal to 3 plus t to the fourth du dt equal 4t cubed, and we get that 4t cubed dt equal to du, and so t cubed dt equals du over 4. So t cubed dt equals du over 4, and so the integral becomes du over 4. 3 plus t to the fourth is u, and so we get u to the 1/4 power, which we rewrite as 1/4 u to the minus 1/4 du. The antiderivative would be 1/4 u to the 3/4 divided by 3/4. Notice the 4's cancel. Of course, we have a constant we add, and the answer is 1/3 u to the 3/4 plus c, and then substituting what u is, we get 3 plus t to the fourth to the 3/4 power plus a constant. We also need to understand implicit differentiation. Very often x and y are related by an equation, and you don't always have y equal f of x, but just a relationship between the variables x and y, as shown here. To find dy dx, we take d dx of both sides of the equation. So for this particular problem, we're going to take d dx of x cubed plus d dx of 2y plus 1 quantity squared equal d dx of y squared. Well, d dx of x cubed is equal to 3x squared. d dx of 2y plus 1 squared is going to be 2 times 2y plus 1 times d dx of 2y plus 1, which is 2 dy dx, equals d dx of y squared, which is 2y, times dy dx. This is all the chain rule. So simplifying this, we're going to get 3x squared plus 8y dy dx plus 2 times 1 times 2 is 4 dy dx equal 2y dy dx. And now let's get all the terms with dy dx on one side. Notice we'll subtract the 2y from the 8y and get 6y dy dx plus 4 dy dx, and we move on the other side the terms that don't have dy dx, and so now we factor out dy dx times 6y plus 4 equal minus 3x squared, and solve for dy dx equal minus 3x squared over 6y plus 4, and you can, if you want to, factor a 2 out of the denominator and get 2 times 3y plus 2. Now you might pause the video and try to do this one by yourself, and then I will work it. Following the procedure, we take d dx of cosine of xy plus d dx of x to the 7th equal d dx of y to the 7th. Taking d dx of cosine of xy, that would be minus sine of xy times d dx of xy. That's the chain rule. Then d dx of x to the 7th is 7x to the 6th, and d dx of y to the 7th happens to be 7y to the 6th times dy dx. Now we have to use a product rule to do this portion. So let's take minus sine of xy times d dx of xy, using the product rule, is x times dy dx plus y times d dx of x is just going to be y times 1 plus 7x to the 6 equals 7y to the 6 dy dx. Now I'm going to multiply this out, and we're going to get minus x sine of xy dy dx, then minus y sine of xy plus 7x to the 6 equal 7y to the 6 dy dx. And I'm going to move this part with dy dx over to this side, and notice I will get, after factoring, I'll get 7y to the 6 dy dx plus x sine of xy dy dx equals 7x to the 6 minus y sine of xy. Now factoring dy dx out, times 7y to the 6 plus x sine of xy equals 7x to the 6 minus y sine of xy. And dy dx is now equal to 7x to the 6 minus y sine of xy divided by 7y to the 6 plus x sine of xy. And here is the answer. Another important thing that we talked about this semester is given position, calculate velocity, and then acceleration. Or given position, the derivative of the position is equal to the velocity. The derivative of the velocity is the acceleration, which is the second derivative of position. Now, in this particular problem, we're given the velocity versus time, and we want to know what is the body's acceleration when t equal 1 second. Well, the acceleration is equal to dv dt, the derivative of the velocity, at t equal 1 second. That would be at this point. We need to find the slope of the curve at that point, and that in this case is just the slope of that line. And you know, the slope is equal to the rise divided by the run. In this case, the rise is minus 2. In other words, it goes down minus 2 from t equals 0 to t equals 2. And the run is 2, so the slope is minus 1 feet per second. Don't know why that went up that way, but anyway, the answer is minus 1 feet per second. Now, this next problem is to find what the body's velocity is when t equals 8 seconds. At t equal 8 seconds, we see the velocity would be equal to ds dt, which is the slope of this line. And you can see the slope of that line, it ends up at minus 4 and starts out at 4. So the rise is minus 8 and the run is 2. So the slope of that is minus 8 over 2 equal minus 4 feet per second is a velocity. Now, another problem that we worked on this semester is to find the area between curves and over a given interval. In this case, you would take the integral from a to b of the upper function minus the lower function, as long as the upper function is, well, as long as the upper function is above the lower function. If, as you know, they change positions, in some cases you would have to find where they cross and change the upper versus the lower. In this particular problem, the upper function is always on the upper and the lower function is always on the lower. So for this problem, we want to calculate the area is going to be minus 1 to plus 3 of the upper curve, which is 4x plus 16, minus the lower curve, which is 2x squared plus 10. Simplifying this, we get it's the integral from minus 1 to 3 of 4x plus 6 minus 2x squared. And we get, as the antiderivative, 2x squared plus 6x minus 2x cubed over 3 from minus 1 to 3. Plugging in, we get 18 plus 18 minus plugging into the 3 here, we get minus 18. And then we get minus, plugging into minus 1, we get 2 minus 6 plus 2/3. And so we get 18 minus 2 plus 6 minus 2/3 equals 22 minus 2/3 equals 64/3 is the area under the curve. Now, look at this function and pause the video and see if you can calculate this area between the two curves. As you can see, we want to calculate the integral from 0 to 2 of the upper function, which is 1/2 x plus 1, minus the lower function, which is e to the minus x. So this would be x to the second power over 4 plus x. The antiderivative of e to the minus x by itself is minus e to the minus x. So this would be plus e to the minus x. Between 0 and 2, so we get 1 plus plugging in the 2 here, we get 2 plus e to the minus 2 minus 0 plus 0 plus e to the 0, which of course is 1. So we get 3 plus e to the minus 2 minus 1 equal 2 plus e to the minus 2 is the answer. The last problem here, we've just got a graph that you need to interpret. Some of the concepts you need to remember is that if a function y equal f of x is increasing, the first derivative is more than 0. And if it's decreasing, the first derivative is less than 0. If a graph is concave up, then the second derivative is more than 0, and if it's concave down, the second derivative is less than 0. So on the graph below, we want to state whether or not the first derivative is more than 0 or less than 0. Label the local min and max, and label the intervals where the function is concave up or down and where it is concave up. Interpreting this graph, we see that the function is increasing from minus infinity to this point, which is x equal minus 1, and it's also increasing between 1 and infinity. So y prime is more than 0 for x from minus infinity to minus 1, and for x between 1 and infinity. Notice in this portion, y prime is less than 0 because it's decreasing. So that's between minus 1 and plus 1. Notice that the function is concave up over this interval. So that's between 0 and infinity. And the other portion, from minus infinity to 0, is concave down from minus infinity to 0. And you can see, just by observation, you have a local max at minus 1, x equal minus 1, and y equal 8. You have a local min at x equal 1 and y equal 4. And that's part 1 of the extra review.